Here we can see the voltage in polar form. So for the loop 1, so applying KVL for loop 1, we get 10 minus J8, 10 minus J8 ohms into I1. Next is 5 ohms plus 5. I1 is flowing in this directions and I2 is flowing in upward directions. So just I1 minus I2. This is equal to 50 angle of 45 degree. So voltage in polar form. So I can write, here is 5I1, 10I1. So 15 minus J8 I1 and minus 5 I2 plus 0 into I3 is equal to 50 angle 45. So this is your equation 1. For loop 2, we have 5 plus J5 into I2 plus 8 I2 minus I3, as I3 is going in that directions. Plus 5 I2 minus I1, as I1 is going in this direction and I2 is in the opposite directions. So this is equal to 0. So I can write minus 5 I1 plus this is 8I2, 5I2 and 5I2. So plus 18 plus J5 I2 and I3 is minus I3. So 8 minus 8 I3 is equal to 0. This is equation number 2. Now for loop 3, 3 plus J4 is there. So 3 plus J4 into I3 plus 8 I3 minus I2 is equal to 0. So I1 into 0 plus the minus I2. So this is minus 8 I2. Now I3 is 3 plus 8. So plus 11 plus J4 I3 is equal to 0. So this is your equation number 3. So we have 3 equations and we must know how to solve these equations. For that we must know the AC mesh analysis. So for any given circuits, we apply Kirchhoff's voltage law, that is the KVL, for all meshes and obtain a matrix mesh equations. So as I have written, impedance matrix into current matrix is equal to voltage matrix. So I is the vector of current phasor, V is the vector of voltage source voltage phasor, and Z is the impedance matrix. So using Cramer's rule, we can find out the unknown current. That is here it is I1, I2 and I3. So now we will use Cramer's rule. So from these 3 equations, we can write the matrix. So first is the impedance matrix. The coefficient of I1, I2 and I3 will be there. So in the first equation we can see 15 minus J8 into I1, then minus 5 I2 and I3, coefficient of I3 is equal to 0. So in V matrix, in the first equation we have the value of voltage. Then others in 2 equations it is 0. We have to find out del 1, that is determinant, del 1, del 2 and del. So in case of del 1, we replace the first column with a voltage matrix. And one thing is we have to convert the polar to rectangular form of the voltage. So it will be 50 cos 45 degree plus j sin 45 degrees. So 50 cos 45 plus j 50 sin 45 is equal to 35.555 plus j 35.555, and others elements will be as it is. Now this way you can solve the matrix. You have to multiply the first element of the first column with 18 plus j5 into 11 plus j4, and both 8 minus 8 means minus 64 as it is now. It is minus 64, minus cancel. After solving this matrix we will get these values, and from this, that is it in rectangular form. Again you have to convert it in a polar form. So you can get these values. So this is very, very important, and do it carefully so that you can avoid the mistakes. Now I have the value of del 1. Then I have to find out the value of del. For del, again I have to write down the matrix as it is formed. So 15 minus j8 into 18 plus j5 into 11 plus j4 . So minus 5 plus 5. You always remember j square is equal to minus 1. So do it carefully. And try to practice it. Otherwise it is very time consuming. For solving this equation you need practice, that's all. So individually you will find out del 1, del 2. So I1 is equal to del 1 by del, I2 is equal to del 2 by del, del I3 is equal to del 3 by del. Again, you have to convert it to rectangular to polar. Put the value of del 1, del. So divide it, you will get the value of I1, and the angle will be subtracted. So 66.97 minus 79 degree. Similarly, we will find out I2, del 2 by del. This way you can directly write down the matrix and you can solve it. Now I am replacing for del 2, replacing the middle column with the voltage matrix. Plus 3 or 4. Here I have written directly the answer, so you try to practice at home. If you have doubt, you ask me in the classroom or in the comments line. So this is for del 3. I will replace the third column with 35.555 plus j 35.555, and I already calculate the value of del. This way we can calculate I1, I2 and I3, which are the loop currents. Thank you so much for watching this video. For more educational videos, please like, share and subscribe this channel.